Everyone, Brian Beeler, and welcome to the podcast. So, last week, if you were listening, we started talking about ruler form factor SSDs with Jason Adrian, who works at Microsoft Azure and also is on the OCP Storage Council. And that conversation has really gotten us propelled down this road of ruler, because it just feels like this technology is going to be hitting the mainstream data center, the enterprise data center, sooner than later. Jason thinks maybe a year and a half. We'll see. But since we did that video and the podcast, Viking has sent us their 1U 24 bay E1S server. So we've got that. We've got hynix SSDs, a box of those as well. And so we're really starting to get our hands on with this technology and getting a great feel for what it's capable of. Because you guys are so interested in emerging form factors and emerging technology, I thought no better thing than to get Viking on the horn here and talk through what they're doing from an engineering standpoint to accommodate for this new technology. So let me bring in my friend here, Odie Killen from Viking Enterprise Systems. How are you doing?
Doing well. How are you today, Brian?
We're doing great. We've got, as I said, for those listening, I've got the server sitting on my desk next to me. I've pulled out a node. I've got a couple of these hynix drives, E1S drives sitting next to me, and we'll talk through all of this. And for those of you that are listening only, you can check out the YouTube companion piece to get the video. But man, this is some really impressive hardware that's sitting here. And actually, before I even let you get started on the hardware, just reset us on Viking Enterprise Solutions. Who are you guys? What do you do, so that our listeners understand that?
Okay, thanks. So Viking Enterprise Solutions is a enterprise storage and server design partner for many of the tier 1 OEMs that you'll find in your data center. We are a branded division of Sanmina Corporation. So we are a design team within Sanmina. Like I said, we specialize in enterprise servers and storage. We have a long history going back into the 1990s. Originally, Sanmina acquired this team through some acquisitions, and we really specialize in the really challenging, high-end, high-performance, cutting-edge products. Is really where we find our niche. And we have some Viking branded products are starting to enter the channel, but primarily we sell through we rebrand our product for our tier 1 partners and sell through the tier 1 space.
Yeah, well, that's helpful. And I think we probably first met you guys at like a supercomputer or something. Like I know you've got a lot of experience in HPC in, you say difficult, I would say maybe goofy designs, not as a pejorative, but as something that you're not going to go, not to talk about your competitors, but you're not going to go to Dell.com and configure something like this with all these ruler bays across the front of it. And maybe one day you will, but you guys are really taking the technology, the emerging technology, and firing it into these systems, even your more standard issue 2U systems. What is that? What gives you guys the capability to adopt new tech faster than your traditional big competitors?
That's a great question. I think one of the things that really helps us is across the team, we have a very talented, very experienced, seasoned team of engineers and technologists and architects. So we have deep relationships with folks like Intel, AMD, Micron. A lot of the key technology vendors in the space are people we have long-standing, deep relationships with, and that allows us to understand the technology that's coming out. And we work very closely with our customers. We listen to our customers to try to understand the best we can what our customers' pain points are, both now and their pain points into the future. And then we turn some very creative, intelligent folks loose on coming up with solutions for those pain points. And so we use the relationships we have along with a engineering team that has a deep history in the enterprise server and storage space to really architect and deliver cutting edge storage and server solutions.
Well, yeah, I mean, like I said, we've seen many of them, even in our lab. We've done testing with you guys before, and this one I'm really excited about. It's funny because your marketing department we're talking to them about getting the you've got a what 102 bay giant 3.5 inch storage system
We
available too.
we have a SAS 4, right? We also have it in SAS 3, but SAS 3 is not
Right,
as exciting because that's only 12 gigabits per second. SAS 4, of course, is 24 gigabits
24,
per
right?
second,
Yeah,
which is very fast, very exciting. We have our first generation SAS 4 uh, 4U 102, 102, 3.5 inch rotating drives. That product is available imminently. I mean, within the next, customers could order that within the next couple months. And that product's available today. Uh, Fantastic product. It fits, and one of the key differentiators of that product is it actually fits in a 1 meter rack. So we have a innovative patented cable management solution that allows us to take a 4U102 product and fit it in a typical 1 meter deep rack, which is pretty innovative, because most of the products with that drive density push you into a 1.2 meter rack. And for customers that are going into colos or going into
yeah.
existing data center solutions, sometimes you only have a 1 meter rack to go into. So, and the SAS 4 data rates are, basically double the data rate from SAS 3. So for us, it's a pretty exciting product. And that product, like I said, is production released and would be hitting the streets here in just a couple months.
Yeah, well, yeah, I just had that in the back of my head and wanted to highlight that it's not just um, these real high-end, high-performance units. That there's also the big, bulky storage stuff that you guys are involved in, and all points between. So specific to Ruler, talk to me a little bit about what you guys are seeing. This is an E1S system, so your short ruler. When I think about these devices, they're just barely bigger than an M.2. It's more heat sink than anything else, like a puffy one of those puffy doodles that's all fluff, and then you get down there to pet them, and then you got to go through a couple inches of curls to get to any dog. But what are you guys seeing in either size of the ruler, the short or the long, that's driving your decisions from an engineering standpoint? I mean, obviously you guys wouldn't be creating this if no one was buying it, or you didn't think anyone was going to buy it, or there was no demand. So what is the real story from your perspective on adoption of next gen form factors?
Well, and that's a great question, Brian. So I think, as with any next gen form factor, there's always a lag, of course, from when the drive vendors come out with their next gen form factor, and you see adoption. But we're seeing more and more of the high performance data center guys looking at the E1.S and even the E1.L form factor. We're starting to see, I think, adoption, mainstream adoption of that is probably kind of 12 to 18 months out, as customers get more and more used to it, as
Okay.
more and more suppliers put systems out in the marketplace. But we think it's a great form factor. It allows us to pack a lot of density in a smaller space because of the form factor. So that shortened height really allows you to get 24. In this case, we have 24 of the larger 15 millimeter form factor E1.S drives across the front. We also had an original concept that had 32 of the skinnier form factor drives across the front, but we kind of, based on customer feedback, we settled in on the taller form factor with 24 drives being the way we wanted to go. So we are seeing more and more customer interest in the E1.S form factor. We're thinking it's going to take off, like I said, probably about 12 to 18 months from now is kind of the time frame we expect to see larger mainstream adoption. But we are seeing it start to encroach into the M.2 space in some cases, where customers are saying, maybe I want an E1.S instead of M.2, so I have more longevity in that device, be it for a boot device or a storage device. So, we think it's a great product, and we're excited about the new form factor. We think you're going to see, as Gen5 starts to come online, you're going to see more and more adoption of E1.S as the Gen5 NVMe and PCIe data rates start to come online as well.
So yeah, and I think we've talked before about that as maybe the inflection point for server vendors in general to kind of take that Gen 5 point in time as the push to do a major overhaul, in which case it's a little bit easier to slot in a new storage design. But go back to M.2 for a second, and this is something that Jason talked about as well, that in the hyperscaler in the clouds, they're doing a lot of these PCIe card sleds with 4 M.2s on them or other machinations to get those into the system. How are you getting M.2s, or what have you seen in the wild to get a lot of M.2s into one system?
So for us, we actually have a U.2 form factor device that has 4 M.2 devices on it. So for us, we have a product goes in our standard U.2 carrier, and it has 4 M.2 modules on it. And so that's one of the form factors we're seeing. We have seen customers put M.2s on carrier cards. We've seen customers put M.2s into enclosures or controllers as boot devices. One of the big challenges that M.2 poses is it doesn't, by its nature, it's not truly hot swappable. So whereas the E1.S is designed to be a hot swappable device, I think that's where, as time goes on, we're going to see the E1.S kind of encroach upon the M.2, and I think that's kind of a limiting factor for, I'd say, large scale M.2 adoption, and that's why you see M.2 modules on, call them carrier cards of some sort, like our carrier card, our carrier device. I'll call it a device because there's some mechanical things to it, so it's more than just a card. Provides that that U.2 form factor, and it provides for the hot swappability and those other things that aren't inherently there in M.2. But we have seen some larger uptake of M.2s, but I really think the E1.S, as time goes on, is really going to encroach into that space, and certainly in the enterprise space, I think you're going to see M.2s kind of get squeezed.
Well, they kind of have to, right? Because the stuff that you're talking about, carrier cards or modified trays, I mean, you still have to power them. You have to connect them to the board. I mean, it's certainly not a trivial task. And like you said, if I'm using, you're talking about hot swappable, but if I'm using an edge card in the server, what do? I've got to shut down the server every time I have to service one of those little teeny gum sticks. And by the way, the thermal profile on those things isn't great either for enterprise workloads.
No, I exactly agree. I think serviceability is a key advantage to the E1.S form factor over the M.2 form factor, and that call it single device serviceability function that's built into the E1.S by design. And you see that in that beautiful enclosure sitting next to you, is you can service each. I'm not a marketing guy, but I had to put my marketing plug in. But you can see that serviceability for the E1.S, and you don't get that with M.2s.
Right. Well, and so there's that angle, and then the density, even on the E1S, we should see the drives I've got here from SK Hynix. These are 4 terabyte class drives, but they definitely have 8, and they probably have 16s of the short still. And then when you go to the long, then the world opens up to 32 is no problem. 64 is probably not that big of an issue either. The question then is really, as the enterprise or as the business, do I want that much storage, or do I need to pay the premium for those density points to get down into 1U? And that's a different conversation. But it seems to me, if anyone's buying M.2 today, that there's almost no. How could you keep doing that? It seems like there's no reason why you wouldn't want to go to the short ruler at this point.
Yeah, no, I agree. And like I said, I think there's going to be an inflection point. I think PCIe Gen5 is that inflection point, and we're seeing indications that that's probably going to be sort of summer of next year.
Okay, so it's interesting to me that you guys, you work with AMD, you work with Intel, you work with NVIDIA, all the Micron, these big guys, and you're always adopting new technology. And even now, as you're talking about Gen 5, You guys are really open in terms of communicating about what you're doing, what you're trying to do, and that's been an organizational thing. I've noticed that from everyone I've talked to there. I don't know if that's a conscious thing or what it is, but the way you guys communicate about, hey, this is what we're looking at, this is what we're thinking about doing, is not so common in this space.
Yeah, and I think that's a differentiator for Viking. I know we're here to talk about the product, but that is a differentiator for Viking as a Viking Enterprise Solutions as a division of Sanmina, is that we
Yeah.
are very customer focused, right? I think we really truly appreciate that we're in business because we have customers, and we're in business to take care of our customers. And if we don't listen to our customers, it's that old adage, right? If you don't listen to your customer, somebody else will. And we want to be the guy listening to our customers and really providing that. And so we do try to keep our finger on the pulse of the industry as much as we can. We do try to lead on the technology side. We have multiple products that, honestly, as a technology person, if you look at them and go, wow, that's some pretty cutting edge technology, and that's pretty cutting edge performance. I'm not saying that just because they're our products, but I'm just, when you look at them, you say, wow, they really do perform, and they perform really well, and they provide a lot of, very positive TCO attributes, very positive performance attributes, and we get that because we do really try to listen to our customers and try to respond to the industry. We don't want to be a Me Too player. We want to be a player that's recognized for our technical capabilities. And the only way that you can do that is you really truly have to listen to your customer base and try to provide solutions that make sense.
All right, well, let's talk about solutions that make sense. I want to get into this ruler system that we've got. I know it's one of your babies and that you're enthusiastic and excited about it. Again, most people consume this on the audio side on the iTunes or Stitcher or whatever, and that's great. But I would encourage you to at least glance through the YouTube video if you're interested in this, so you can see some of the things that we're talking about. I haven't even started to talk about the server other than the 24 E1S bays in the front, but this is one U with 2 compute nodes in it too. And as usual, you guys, I haven't torn the lid off yet, are light on cabling, shall we say. Is this another zero cable design?
For the most part, and certainly in terms of the data path, it's a zero cable design. We certainly, part of the lineage that we bring is a long lineage of enterprise class servers and storage. And so cables typically, sometimes they show up in an enterprise class product, but for the most part, the fewer cables, the better, the more, we'll say, rigid connections you can make with connectors and PCBs and mechanical fixturing in the product, the better it's going to withstand things like shock and vibe and operational vibrations and all the things that typically can degrade performance or degrade reliability of a system. We make every effort to design those out. So yeah, there's not a whole lot of cables in it. The server that you have there is an AMD Milan-based Gen 4 CPU with anything from, you can get that in a low core count to a high core count solution. You have multiple PCIe slots supported per server, dual nodes. So, each node can communicate to 12 of those E1.Ss. So from a performance perspective, you've got tons of back-end high performance Gen 4 devices talking to your PCIe core, in the AMD CPU, talking to the host PCIe devices on the host side. So from a performance perspective, it's designed from start to finish for high reliability, high performance, pretty slick.
Yeah, so let's start at the front and kind of work back. So as I've said, they're 24 bays across in this 1U server. The drive height, as you said, you standardized on this 15 mil spec, so it's a standard U.2 Z height, same thing, it's just shorter. You're direct connecting the SSD connector to a little L-shaped dude on the inside here, I think, that's on the board, right? There's nothing in between this drive when it slides in the connector. Is that right?
Correct. Yeah, that drive plugs directly into the connector. Excuse me. And then there's, some PCB interconnect that we provide that allows that connection to make it directly into the CPU complex. One of the benefits we have with this particular CPU architecture that we've chosen in that controller is that CPU has a ton of PCIe lanes, so we're able to go
Right.
direct connect from the CPU to the to that device, to the E1.S device, and as a result, you don't have the extra latency of switches. You have a very high performance solution. You have, as much bandwidth as the drives can provide directly connected to that CPU. So very high performance solution.
And so you said 12 drives go to each server node. Is that how it's configured?
Correct. Yeah.
So in the past, I think when we've looked at some of these NVMe solutions and U.2 from you guys, both controllers could see all the drives. Then we would do something like namespaces or something to carve up the drives and distribute them. This model of not cross-sharing the SSDs, is that fundamental to ruler design where that's better? Is that customer feedback? Are they? I haven't even checked. Are they not dual ported?
They're not dual ported. So that's,
yeah, there you go.
Right. That's the primary reason that it's we call it a dual node, or some people call it a shared nothing design. So that's the primary reason, is those devices are not dual ported. So with dual ported devices, like on our 2U product, based on the U.2s, which are dual ported, we have both a dual node and a HA high availability redundant topology available in that product. But since these drives are single ported drives, we decided to go out the chute with a dual node solution.
And so in that case, then customers are going to want to rely on application resiliency, maybe a little bit more than hardware resiliency with something like this, I suppose.
Yeah, correct. I mean, and so depending on the size of your enterprise, which really dictates what you would do. I mean, some customers would run basically redundant copies of data on multiple nodes. Some customers you could take multiples of these and run erasure coding on the controller to build a bigger erasure coded node where, multiple chassis become different pieces of different nodes within that erasure coded topology. So there's a lot of flexibility that's built into this, but you are limited by the E1.S single ported nature.
Well, I mean, 12 still sounds like a lot for a single CPU, even with all the lanes that AMD has. I mean, certain workloads will work this thing over pretty good. So that's interesting. Talk to me about cooling, because I know there's a cooling bank somewhere here about 8 or 9 inches deep. What changes, if anything, for these drives versus U.2 from a cooling perspective?
So when you think about from a cooling perspective, these drives are a little more challenging to cool. It takes a little more thought in the thermal architecture for this, in that these drives have comparable power profiles to a U.2, but when you think about a U.2, that device is twice as tall, so you can get an overall greater, I mean, without getting too technical, when you think about cooling, you do heat sinks, so you can basically increase the surface area, and you increase the surface area, you get airflow to the surface area, the heat goes away. One of the challenges of the E1.S form factor, especially the the S being the shorter, is that overall surface area that you're able to create for convection cooling decreases. And so because of that, you have to do some things like move more air or duct, or do some other things to get better airflow over the devices to ensure you get proper cooling. So we do have call it a traditional front, cold aisle to hot aisle, front to back, forced airflow cooling system in there with high performance fans, redundant high performance fans, hot swappable, fan units are hot swappable. But again, I mean, that's one of the things that as a supplier with a deep history in this space, we're able to leverage that expertise to come up with a thermal solution that really works for this.
Okay, yeah. I mean, just looking at the heatsink on these and thinking about how that works, it's that's going to be something that pops up, right, when you jam all these drives together in one little box. How do you make sure that you can, well, power them and then cool them, which is sort of fundamental to it. But the fins, I guess, create quite a bit of surface area on the one side, and then just the flat back. From a design standpoint, I know you've got these little caddies that clip onto the front of the drive, and then they slide into the server. What challenges do you have to deal with in terms of physically mounting the drives and securing them in the server?
Well, one of the big challenges is you're kind of, for lack of a better word, you're kind of stuck with some mounting characteristics of the device, right? The heatsink, you can use the heatsink for mounting, but you're kind of stuck with that form factor, and you don't have a lot of extra height above and below. So you really have to rely on a mounting, call it a mounting track, to get the device to line up with the connector. Good news is, that connector has, by nature of that connector, it is designed for blind mating and hot swapping. So there's gather in that connector to get the alignment straight, to get everything aligned properly for hot swapping. And then you really just have to fixture it from the front, which is where that little caddy that we have, that you called it, attaches to the drive and provides an interface into our enclosure to mount the device securely, and provide the EMI containment on the front of the enclosure to keep the EMI performance where it should be for the product.
Well, yeah, I mean, that probably gets to it, because Kevin and I were talking today when we were looking at this and sort of dissecting it a little bit, thinking, gosh, wouldn't it have been nice if they just added like a little finger hook on the front of the heatsink, so that you could just take the drive, there's already a track there, and just boop, plop it in, and slam a bezel and be done. But not so simple, I suppose.
Yeah, and if you did something like that, it moves your EMI containment. And for those in this, that do this, I think most people will tell you EMI containment on a per drive basis is always easier than EMI containment over the entire front. You just have a smaller, the EMI containment really relies on good mechanical fit. And so the shorter the interface you're working with, the easier it is to get a tight mechanical fit.
How are you handling, I know this is kind of getting into the weeds and most people won't care, how do you handle drive blink on these and other visualizations? Because I think about, you've got this one server, but if I put 50 or 60 of these in a rack times 24 drives a pop, and now I've got to go service a drive that's out, when you're counting, it's harder than it sounds to count by rack when you've got to figure out position 37 to make sure you're still on the right one when they're this small. What from a serviceability standpoint, what are we doing with lights and visualization?
So we do bring lights out. So the product supports lights along the front, and then we also build in enclosure level identification. So from a GUI perspective, you'll know, okay, I have, just making up numbers, I have 40 of these 1U chassis in my infrastructure. Now it's chassis number 25 and it's drive number 13. Okay, well, geez, who knows which rack that is? So you identify the enclosure. So you turn on an LED to identify the enclosure. So when you walk up, you see there's an enclosure. Oh, okay, it's this enclosure because it has a blue LED, and you can make it flash or you can make it solid. You can do different things through the software to get the behavior you want.
Right.
And then we'll turn an LED on. You can turn an LED on the particular sled to say, okay, it's 13. Oh, there it is. It's that flashing light. So, that's part of the long-standing enterprise serviceability features that we bring into our products.
Yeah, and now you have to, though, maybe have a little more pinch strength to be able to get your fingers in there and hit the release and pull the drive out. But hey, at least it's hot swappable, right?
It is, yeah. Definitely, definitely a step up from a serviceability perspective to be able to hot swap individual SSDs.
So when you, I mean, I was going to ask you about Gen 5 again because I started thinking about something here. But before I leave the form factor discussion, you did talk about long a little bit. Historically, I think, and maybe you can correct me, these systems have either been short or long. But can they be combined? Is there any sort of future where I could use the small rulers for my performance data needs and use the long ones in the same system for capacity?
There is for the product you have in front of you. You can certainly support that, and that's certainly on our product roadmap to come up with a product that supports both.
Oh, wow, that'd be pretty cool. Are you guys doing anything on long right now, or is it just on the short?
Primarily on the short. We have some long concepts in work, but right now we're primarily focused on short.
And that's just a customer demand issue, I assume, right? I mean, you're
Exactly.
going where.
It's a customer demand issue.
So is 1U still the forever right answer for this thing, or does going to 2U and 48 drives do something different? Are there other ways to skin this cat?
I mean, there certainly are other ways to skin it. The challenge you run into is, at 30 watts a device, if you have 24 of them across the front, that's, roughly 720 watts if my Wednesday feeling like a Monday math works out. And that's a lot, right? And you throw in a server, and in this case, you throw in two servers.
Or two, yeah.
And then you throw in the performance. So it's a balancing act. And so there are certainly other ways to skin it. And I think, honestly, Brian, it's a kind of a customer and performance application dependent question. Because you could, if you load too many of these devices in, you could come up with a situation where you just can't get enough compute power and IO, front end IO into the box to be able to fully maximize the stuff on the back end. And one of the things we always try to consider is, where are the bottlenecks in the system? And so I think the short answer is yes, there's absolutely other ways you can do this. You could do different topology. There's a ton of different topologies you could use from a mechanical perspective to cram more of these into a box. But from a performance and system bottleneck perspective, I think there's a lot of trade-offs that you have to look at, and it really comes down to, what do you want out of your system? What we found is a good general, one size fits most. I don't want to say one size fits all, but one size fits most approach is the 1U 24 drive solution we have there. Just is the best one size fits most solution we came up with.
Well, I mean, out of the gate, it makes intuitive sense. And listening to you talk through, the power is a huge thing. If you were going to double this, and I guess doubling doesn't really get you much, though, because if we're talking about what the kind of performance we can deliver to the CPU, once we've overwhelmed that, then anything else that's sitting in there is just kind of suboptimal, I suppose. So you'd be better off perhaps with more systems, more multi-node. Do you guys do one of these, or have you looked at doing one of these that's only a standard 2-proc single server board rather than the dueling boards?
So we certainly have. Again, I mean, it comes down to customer demand. One of the things we pride ourselves on is we look at a lot of different concepts, and then we bounce concepts off of our customers, talk to our customers, and try to come up with solutions that best fit our customers' needs. And so right now, that is a concept that we have looked at, some dual socket, single server dual socket solutions. We don't have one in this E1.S space today, but it is certainly a concept we've talked about and looked at.
Yeah, well, I mean, I'm sure, given what I know you guys make, it can't be much of a technical challenge. The challenge is a market challenge, perhaps more than anything. So I brought up Gen 5. We've talked about it a little bit before. What about Gen 5 is so exciting for you guys? when you look at a system like this?
I mean, I guess the most exciting thing about Gen 5 is when you think about it, man, it's fast. I mean, Gen 4, when you think about Gen 4, and you just think about the throughput you get out of a Gen 4 system, right?
Mm-hmm.
It's Gen 4 is exciting. Gen 4 is an exciting technology. Gen 4 gives you amazing throughputs. And wow, you're twice as fast with Gen 5. I mean, it certainly poses, it's exciting as a technology guy who loves challenges. It's exciting as heck because when you think about what it takes to physically implement Gen 5, it's hard. I mean, it is hard. So from a technology perspective, you think about the challenges, and as an engineer, I love challenges. What engineer doesn't love a good challenge, right? So from a product perspective, any product you do with Gen 5, and we are currently working on some Gen 5 products, is just exciting, right? I mean, it's just the geek in you comes out and you just go, man, this is some fun stuff we're working on. It's really exciting. From a product.
Well, why is Gen 5 so hard? Why is it fundamentally different than 2, 3, or 4?
So I'll try to not geek out on you, keeping in mind when I did my master's work, it was in EM field theory. And it gets into EM field theory stuff. So I'll try not to get too excited on you. But the fundamental data rates increase. And so when you think about, like you mentioned, there's no cables in that product there. When you run on PCB, as the frequency increases, the losses increase as well, right? Mm-hmm. So as Gen 5 comes along and the overall budgets, the signal integrity budgets, the loss budgets, get a lot harder to stay within. And so one of the challenges you run into is where before you could have your drive, just making up numbers, but you could have your drive 16 inches away from your CPU with Gen 4. With Gen 5, it can't be 16 inches away. It has to be closer. So from a design and layout perspective, the physics associated with making Gen 5 happen are really going to challenge traditional paradigms of how things are done and how things are put together. And so I think from a Gen 5 perspective, it's going to be challenging. I think people are going to struggle to get their first products. I don't think we will, because we're investing in it now, and we're investing a lot of really talented people's time and energy into making sure our Gen 5 products come out right. But I think for a lot of folks, Gen 5 is going to be a challenge just because of the physical constraints associated with those data rates are really going to push everybody in that space to really do a better job. And Gen 5 doesn't allow for any sloppiness in your work.
Well, I've got two things that concern me about Gen 5. First, the idea of an SSD that's going from 7,000 megabytes a second at the high end to 14 or 15,000 is pretty impressive. But then the CPUs aren't fast enough to really make work of all of these things all the time. So we'll have to see, what Intel and AMD and ARM to a lesser extent maybe can give us there. But then once we do all of that, we're back to this cooling issue again, where the fans are going to be under tremendous load. How far away do you think we are from mainstream liquid cooling or some other methodology for enterprise data center systems? Can we make it another couple of years on air movement alone?
I mean, that's a loaded question. But and I think that question depends on who you talk to. I certainly believe, Brian, that Gen 5 is achievable with I'll say, traditional, air moving cooling methods with good sound engineering work. I think Gen 5 is achievable with that. When you start getting into they talk Gen 6, Gen 7, all the subsequent things. Um, then I think you start making trade-offs at a system level, and things like disaggregation come more into play. Um, Breaking things up and actually disaggregating, not necessarily disaggregating the different pieces of the hardware, but disaggregating the way you manage your data come into play. And
Hmm.
so maybe you go to smaller, instead of having a server with a ton of storage, maybe you have multiple smaller servers with less storage behind them. Uh, I think Gen 6 is really going to be, so call it 5 years from now. I think you're really going to see an inflection point where there are going to be market shifts, because you're right. I mean, as we go further and further and further, the cooling demands get harder and harder. But the other challenge is, I don't know the number, but I know there are a huge number of data centers out there today, colos and wholly owned dedicated data centers that don't support liquid cooling
Right.
and are not planning on supporting liquid cooling and don't really have the capacity to readily switch over to liquid cooling. So although you may have products that need that or would benefit from that, I think the switch over to liquid cooling isn't going to be, it's not going to be a light switch. And I think because of that, I think you're going to see kind of a divergence. I mean, and this is just me guessing, and nobody's crystal ball is perfect, and mine certainly isn't. But I think you're going to see a divergence where the liquid cooling is going to come up in some segments, and those segments are going to be newer segments. And then you're going to see a shift in product topology to allow the newer technologies to work with a more traditional cooling approach. So I think it's going to be an interesting time, that's for sure.
Well, what do you think that means then? Do we look at a standard box and say, okay, well, we've got to cool the CPUs. They're really hot because they've gotten so powerful now, and we've got to do something there. But we've got all these drives out. Well, why don't we just yank all the drives out, put them in a JBOD or a JBOF if you want to be the trendy flash guy, and then connect to the servers over fabrics. That way, the servers have no storage at all. Maybe a M.2 for boot, but have no other responsibilities other than their applications, and then just reach across the wire to get a localish feeling SSD. I mean, is that something you see as a possible answer, or at least a stall for having to deal with these greater heat problems?
I think all of those things are possible. I think you could see the disaggregated model take more flight, where you have um, a better implementation of the different storage tiers. We talked about the storage tiers where you have flash and you have rotating media and you have nearline media and you have different speeds of rotating media. I think you'll see more tiering coming along. But one of the challenges you have is still there are physics limitations associated with these higher speeds as we go faster and faster and faster. So even though we may disaggregate the storage from the server, the storage from the compute, you still have a physical limitation of physically how long that wire can be or how far that can be, without making trade-offs in things like speed or latency or things of that
Hmm.
nature. So I think what you'll see is, and this is me speculating. I think what you're going to see is the speed of evolution of the system is going to slow down a little bit as we get a little bit faster and faster, because it's going to take people a little bit longer to figure out what the optimal answer is. And you're going to see some disaggregation. You're going to see disaggregation of storage from the compute node. You're going to see um, a disaggregation, or not a disaggregation, but a more decomposing of the data and the data processing. So different parts of the data will be processed more parallel processing, I guess is what I'm trying to say, of
Hmm.
data with smaller chunks of compute and storage that can manage those speeds and feeds a little bit better, with that data being brought back together somewhere else. I think you're going to see I think it's going to be a really exciting inflection point where you'll probably see two, three, four very distinctive trends trying to emerge. And I think eventually they'll kind of settle down and converge back into one or two streams. But I think you're going to see a divergence coming.
Well, I think you're right. I mean, we've talked to NVIDIA about DPUs. I mean, they think the JBOF thing is very real, and that's great. We talked to a lot of the software defined storage guys, and ultimately, I think those are the guys that really need to help accelerate the adoption of these alternate frameworks, right? Because eventually we'll need software to tie it together, and whether it's like OpenShift or something like that for telcos, or whoever's taking advantage of those specific use cases for some edge workloads or content distribution or whatever. Those things are getting smarter. The software is getting smarter, and it's able to better take advantage of systems that could be separated out from compute and storage. It'll be really interesting to see what happens with the traditional storage array world, because people have been talking about the death of the storage array for at least a decade or more, same as fiber channel, but they both keep sticking around. But how long until as you say, that there's some shift in the way that storage is deployed and consumed that makes it easier to not have the array, to have componentry, or to have software that's intelligent, or something else to be able to do these things. We see Liquid kind of working on it, not kind of, they're really working on it. Fungible's got a storage solution that they're working on. Others are there. I mean, you guys are knee deep in it too, right? I'm sure in working with all these partners to try to figure out what sort of enablement they need.
Yeah, absolutely. And I think I don't think the array ever truly dies. I think it morphs. I think it changes. I mean, think about these things right here, right? The amount of data
your phone, right?
Yeah, I mean, the amount of data being generated from, I mean, I've got two 15-year-olds in the house. I mean, the amount of useless data that we generate that goes on Facebook or the other social media apps is just mind blowing. And unfortunately, that data is gonna, and there's useful data there as well, but that data is gonna stick around. And as long as, and think about things like, my wife works in healthcare with HIPAA and the transition of medical records to being digital, and all the other, I mean, the list goes on and on and on and on. I think the array stays. It may morph, it may change. I mean, I don't think, I'm one of those guys that falls in the camp of rotating media never goes away, or at least until there's something better. And right now, device physics don't really support flash replacing the array just yet, or the rotating media just yet.
Right.
So I think rotating media stays around. I think there's always going to be a demand for it. I think, but to your point, Brian, I think you're absolutely spot on. The way we access that and the way we control that and the way that array fits within the network and the infrastructure in the data center and in people's deployments is going to change. Absolutely. I don't think it ever goes away though.
Yeah, I suppose not. And that'll be music to the ears of most of the legacy IT guys that very much need that revenue to keep coming in, whether it's array sales or as a service or on demand or whatever. I mean, the consumption models are definitely changing, but that's another issue. So we talked Gen 5. We talked about some more options that you may be looking at in the future for systems like this that use ruler. Anything else? I mean, this is an AMD system. I assume you'll probably do an Intel. You guys like to be able to support both ecosystems. What else are you looking at for a platform like this over the next several months?
So we are looking at an Intel solution based on their Gen 5, next generation Gen 5 CPUs. So we have an Intel solution in the works. We'll have an AMD Gen 5 solution in the works. That product that you have right there will definitely support both of those. One of the things we like to do is that controller you have is in a 1U form factor right now, but with different sheet metal and different riser cards. That same controller can be leveraged across our 2U platform. So we have some pretty exciting things coming. We have, like we were talking about, within that product set, you have a controller there, but we also have we have an IOM version that's coming out for this product. Well, we have an IOM version that can go in that product today that supports we have 2 partners that we're actively working with and some others that we're bringing up for different fabric modules. So we have we could turn that into a simple dumb JBOF, turn it into a very advanced, very highly full-featured array with a different partner that has a much more intelligent card. We can support, some of the other off-the-shelf cards that are out there today, some of the GPUs and other cards that are available today. We have a common controller set that works across our 2U24 product. We have a 2U56 product. We have a refresh coming on our 2U56. So, you talk about density in the 4U102 product. We have a 2U56 that supports 56 U.2 NVMe devices. So extremely.
Is that using side bays, or do you have a second mid plane in the middle?
Side loaded. So it's side loaded. So that's an extremely high performance product that's going through a refresh as we speak. That is targeted over the next 6 to 9 months. So a lot of very exciting next gen storage products coming out from our team.
Well, we know who to call to get the new cool stuff. Then, and we'll make
Absolutely.
We'll make sure to keep doing that. Well, this has been a great conversation. Really, our guys here in the lab and our readership and viewership is really interested in this emerging tech and seeing what's coming. Rulers, like I said at the beginning, maybe 18-ish months. You think maybe a little sooner to get this more mainstream. So I hope you're right. It's certainly fun to see new things coming, and we look forward to working with you guys on this and then whatever comes next. But either way, appreciate the time today on the podcast and on the video version as well. And you guys are awesome. Thanks, appreciate it.
Thank you, Brian. Appreciate being here. Thank you.
And thanks for everyone else for tuning in. We'll be back with another podcast soon.